I'm Bruce Bugbee, president of Apogee Instruments and professor at Utah State University. We're honored today to have my colleague, my long-term colleague, Marc van Iersel, here with us at the Apogee recording studio, both to visit at my laboratory at the university to talk about science, but also to talk about commercial implications of all that science. Marc and I have been colleagues for many, many years, many decades even, and we've shared students back and forth. It's been a wonderful collaboration. The thing we want to talk about today is exemplified here on the board, what we call precision photon delivery. So now that we live in an era with LEDs, wow, they give us unprecedented ability to control the delivery of photons, and not just focused photons, but changes in timing of the photon delivery. So in this case, when we say precision delivery, today we're going to mostly talk about precision delivery in time of these photons. So, Marc, do you want to start by, how has your university research informed this, and how has it led to Marc has a company called Candidus that makes software and hardware to achieve precision photon delivery. So he's right in the middle of all of this. But do you want to comment on how your university research has informed all this?
Yeah, absolutely, and thank you for having me today, Bruce. So I started working on lighting research about 8 years ago, and when I decided to do so, what I identified as a niche that nobody else seemed to be paying attention to was how can we actually control LED light fixtures very precisely to give plants the amount of light that they need at the time that they need it and can use it most efficiently. So that's how we started out. Since then, we have gotten a big USDA grant where we are collaborating with Bruce's Utah State University lab, but we're also collaborating with fantastic electrical engineers and people in energy informatics who have helped me see the bigger picture of how you can actually do this, how you can optimize lighting, and how this can impact society at large, which ultimately makes all of this work much more exciting. So it's been a fascinating evolution over the past 8 years where I've learned lots of things from working with lots of people who know things that I do not. It's been great.
Just to elaborate on that for the listeners, it's probably close to 5 years ago now, we collaborated on a large grant to the USDA to look at optimizing lighting. And this project came to be called the LAMP project, and I think you're the one that coined that phrase, LAMP, lighting approaches to maximize profits. And of course the USDA is very interested in optimizing this, and the whole thing is lighting approaches. So now with USDA funds and collaboration of multiple laboratories, we've done a lot with this.
Yeah, it's been a great project, and so it's not just plant scientists that are involved. So I think the key word actually in the title of the project is profits, and when we think profits, we have to think economics, right? Because Bruce and I typically really tend to focus on the plants. How do we grow plants? And that's really fascinating stuff, but if we don't take into account the cost associated with that, then ultimately we're not serving the controlled environment agriculture industry, plant factories and greenhouses in the way that we need to. Because yes, they need to grow plants, but more than that, what they have to do is be as profitable as they can be. And that has really required this interdisciplinary work to get these different perspectives on how we can do things beyond just plant science and horticulture.
Yeah, in this grant we all joke because the currency for us as professors is a bunch of refereed journal articles, which, as you know, can be pretty egghead journal articles. And the USDA doesn't want to see a bunch of egghead refereed journal articles. They want to see boots on the ground. They want to see how all of this work is going to help growers.
Yeah, and that is actually where my company can also play an important role. So as academics, we can develop all these methods. We try them on a relatively small scale, but as academics, we have relatively little incentive from our institutions to try to make sure that these new technologies actually get implemented at scale throughout the industry. But so at Candidus, we are very focused, of course, on making sure that we get this technology into commercial facilities. And we have an additional project with a different branch of the USDA, the National Resources Conservation Service, where Candidus works with them on not just showing that we can achieve significant energy reductions through better lighting control methods, but what we really are focused on there in the long term is to develop guidelines to develop incentive or rebate programs for the industry to help them get this technology into their greenhouses. And so I think that is a really exciting long-term thing, because those incentive programs are going to really help make this technology accessible. And certain utility companies, especially in the northeast of the US, are already providing rebates, not just for better lights, but for better lighting control systems. So we really see this movement happening, and that's a great impact of Project LAMP.
And I think most people know now that every passing year there are fewer and fewer high-pressure sodium lamps used and more LEDs used, as the LEDs get both more reliable and more cost-effective. And of course, it's a nice synergism between us, because first of all, you got to precisely measure the photons, and then you use the software to figure out how to deliver the photons.
Yeah, and the change from high-pressure sodium fixtures to LED fixtures is really important when you think about controlling lighting. With high-pressure sodium, maybe you have some ability to dim them, depending on what fixtures you're using. But once they take some time to heat up and give you full light output, once you turn them off, they need time to cool down before you can turn them back on. So you can't get real precise control over how much supplemental light you're providing in the greenhouse. With LED fixtures, almost all of those are fully dimmable at this point in time. And that dimmability allows us to very precisely control exactly how much supplemental light we provide in response to how much sunlight is available at that particular point in time. So LEDs have really opened up a whole new area to make this lighting control much more beneficial for the industry.
Yeah, all of us at our research greenhouses were pushing the envelope with high pressure sodium, trying to cycle them faster to get this variable control. And we burned up a lot of capacitors and a lot of high pressure sodium lights, trying to push them to the edge. And that was expensive, having to rebuild these lights all the time. So, and this is something that people don't think about much with LEDs. They think, okay, great, they're more efficient. But man, they're so much more controllable. We're just on the threshold of taking advantage of that.
Yeah, I really think that it is the next frontier. And when I would talk to the industry about this topic 2 or 3 years ago, people would go, that's pretty interesting, never thought about this. But I was at a trade show just 2 months ago, and it's really satisfying to see that we have to explain much less what we're doing, because people are getting the concept. And I think when it comes to lighting, control of how many photons we deliver when is really the next frontier. LED fixtures are great, but they're starting to push the theoretical limit of how good they can be. And advances in the efficacy of LED fixtures, they're going to slow down, but we can still make big improvements on actually how we use those fixtures in commercial facilities and in research facilities as well.
An analogy, I guess as teachers we're always trying to think of analogies that help explain things. But analogy for me is being like a high-performance athlete, where when you eat and what you eat makes a big difference in your performance. And here with HBS, it's, well, you can have a steak dinner or not a steak dinner. And now we could have almost the equivalent of like precision intravenous feeding to deliver the photons at just the right time for maximum performance.
Yeah, and that's absolutely correct. There are really good quantum sensors available, of course, including from Apogee. That information is really critical, but you can interface those with really cheap microcomputers that can take those readings, apply really advanced algorithms to that real-time data that feeds in, and then those microcomputers can send a signal back to the light fixtures and tell those light fixtures exactly what they need to do. And at Candidus, we tell light fixtures every 15 seconds what change we want to make sure that by the end of the day or by the end of the growing cycle, that crop has received just enough light to do exactly, to grow exactly how it needs to grow, but without providing more light than is really required. And that excess light that is often provided in greenhouses is really expensive. And in some cases, I think that can make the difference between a greenhouse being profitable versus losing money. And so we really want to push those facilities towards profitability.
It's pretty intuitive. On a partly cloudy day, when the sun comes out, you can turn your lights down because you got sunlight. But 5 minutes later, sun goes behind a cloud, and now you need to turn them back up. And of course, this is what we're talking about, that level of controllability. But Marc, first of all, Marc just gave an invited talk at a controlled environments conference. It was a conference in Tucson that we both were at. But he gave a talk about this, and I wonder if you could elaborate a bit more on the variable price of electricity and how that enters into this.
Yeah, I think that is a really fascinating topic, and the reason that we are working on this topic at the University of Georgia is because I have colleagues in engineering and in energy informatics who understand these things much better than I do. But it seems pretty intuitive that if you have variable electricity prices over the course of a day, you want to provide as much supplemental light as possible during times of the day that electricity is relatively cheap. And so my colleagues in engineering have developed algorithms that can take advantage of that variable electricity price. And now the goal is no longer to minimize the amount of supplemental light that we provide to meet a crop's need, and that's what I did in the past. We are now able to actually control lights based on how can we minimize the cost of that electricity. And of course, when you think about that from a commercial perspective, that is really what they need to do. And so we have developed algorithms that can do this really well. And those algorithms reduce the cost of electricity use by about 35% over less sophisticated methods that are actually probably still better than what is commonly used in the industry. Likewise, at Candidus, we have done a number of trials in commercial greenhouses with our proprietary lighting control approach, and we typically reduce electricity use by about 30% without a notable impact on the crop. The plants grow just as well, but that is a lot of money that you end up saving, because the cost of providing supplemental light in a greenhouse can easily be $60,000 to $70,000 per acre over the course of a lettuce growing cycle. So if you can cut that by about a third, that's, in my book, quite a bit of money.
Yeah. Not everybody understands the issues of variable electricity pricing, other than we know they often vary. But when a utility company gets the infrastructure to provide electricity, if they don't use it, it's hard to store electricity. And so they end up purchasing electricity that they can't use certain times of the day. And they would love to have customers use that surplus electricity. And then the opposite, the common thing is late in the afternoon, everybody's air conditioners come on, and now the cost of electricity is just enormous. Well, we could just turn the lights off during those periods of peak demand. So this interface between big greenhouse growers and utility companies has a lot of potential to help the utility companies efficiently utilize their capacity.
Yeah, and what we have actually seen in the past weeks in the United States is that people in California have been asked to turn off their air conditioning units or turn up the AC to maybe 78 degrees. Texas has massive problems with their utility network not being able to provide enough power for all of their customers during peak times. And so actually at Candidus we have collaborated quite a bit with utility companies to try to help them shift the electricity use in greenhouses away from those peak hours. And this is a really important topic for utility companies. And that's why I think ultimately we need to get the controlled environment ag industry hooked up with the utility industry so that we can come up with solutions that are actually beneficial for everybody. And then hopefully we can have a positive impact on society as well. So we're really focused on creating a win-win-win scenario there.
So if you tell people, just suffer, turn your AC up, they're not very happy about that. But we don't usually consider the plants get happy or sad. If we just tell them we're going to give you the photons a little later, the plants grow just as well. And that's the issue here.
Yeah, and that's an interesting topic, because the conventional wisdom and what we tend to do in controlled environment agriculture is we want to control everything really precisely. I think those of us who are working in controlled environment agriculture, we tend to be, as I like to say, control freaks. But we've actually done quite a bit of research at the university that has shown that plants actually don't really care about that precision control. They're perfectly happy if you give them more light now, less light later, maybe more light today, less light tomorrow. And that was, first of all, was really surprising to us, but it was also really exciting, because that now allows us to really take advantage of time periods that electricity is relatively cheap, and it's provide a whole new frontier for this precision photon delivery, because we don't have to keep the light levels in a greenhouse as stable as we possibly can. So that can be really beneficial for the industry.
Mm-hmm. Mm-hmm. So just to switch topics a little bit, I want to ask you about how did you choose the name Candidus for your company?
Well,
people ask me, how did you choose Apogee? Well, it's the point in an orbit farthest from the Earth. And I was doing a lot of work with NASA, so that was kind of a no-brainer. But Candidus, that's an unusual name. How did you come up with that?
It's kind of an interesting and maybe funny story. So my co-founder, Erico Matas, asked me if I was willing to co-found a company with him to work on lighting control systems. And I said, yes, I'd be excited to work on that. And of course, the very first thing we needed to do was figure out, well, what is the name of that company going to be? So I spent an evening on the internet, and I was interested in either Greek or Latin words that had some connection to light, because our focus, of course, is on light. And so I found all kinds of terms, but most of those were already in use by lots of other companies. And I finally came across Candidus, and one of the meanings in Latin is light. But another meaning that pushed it over the edge is gray-haired. And I said, that's it. That's what we're going with. I sent an email to Erico. I explained it. He laughed and agreed. And here we are.
There we go.
So I'm the official spokesperson for the company.
Wise elders helping you better utilize your photons. Well, Marc, it's been a great run that we've had back and forth over the years, and it's so exciting to be working in an area that has both lots of opportunities, profound scientific discoveries, but commercial opportunities too. They're very synergistic for both of us.
Yeah, as you well know, it's really exciting if you can take the work that you do at a university and through a company really help to scale the work that we do in an academic setting. And there are lots of things in my career that have been rewarding. Perhaps the most important thing is all the people that I've worked with, the graduate students that I have trained. But I think now seeing this technology spread through the industry, that is really rewarding in a different way, because I can tell that we're making a positive impact, not just on the industry, but I think we're having a positive impact on society too. So it's really exciting to be involved.
This meeting, it was this last week that we were together in Tucson. It's a controlled environments conference. And when that first started, a long time ago, back when we were much younger, it was a bunch of academics sitting around a small table discussing science. And that was the whole meeting. And as the basic science found applications, commercial people started to want to come to the meeting. And sure, come to the meeting. And the group grew. And it grew. And it grew. And the growth chamber people come, lots of LED people come to this, instrument companies come to this meeting now. And so now we had over 200 people at our last meeting, which started out with a bunch of egghead people discussing some pretty refined points of science. It's just a remarkable transformation.
Yeah, well, as you commented on during that meeting, well, you've probably been part of it for about 30, maybe a little bit longer years.
Yeah, over 30, yeah.
And controlled environment was really just a research tool where we could do research that then might or might not have practical applications. A lot of it was pretty basic research that was done in growth chambers, basically. But when you now think about controlled environments, there is a very large controlled environment agriculture industry. We have a number of large vertical farms, and they keep growing. And on the greenhouse side, the greenhouse vegetable industry is just exploding. So I think that is, at least to some extent, really a long-term result of the work that people like you were doing 30 years ago already. And now we see a real transformation of how we actually grow vegetables.
The earliest stuff was mostly NASA funded. We got NASA funding, and NASA can't really have a greenhouse on the moon or Mars. There's no atmosphere, it has to be pressurized. Meteorites would break it. NASA has to use electric lights in a closed system. And those were the early days, but boy, as soon as LEDs came along, it just exploded for commercial opportunities.
Yeah, although I remember some of the first talks at this very meeting about growing plants under LEDs, and it was really interesting. You saw beautiful pictures, but only NASA could actually afford to buy LEDs because they were so expensive, and quite frankly, they were very, very bad compared to what we have now. And for a long time, I was not convinced that this would be something that would ever become commercially viable. But of course, by now, it has completely changed, and LEDs are really efficient. There's probably never going to be a different kind of light that is going to come along that is going to replace LEDs, because LEDs are so good, and they will be the choice for growing plants, whether it's indoors or in greenhouses.
Yeah. Well, we talk about this all the time, but if we look at the history of electric lighting, if we go back far enough, it was monks with kerosene lamps walking from room to room. What's the energy efficiency of that? It's teeny, it's tenths of a percent, turning energy into light. And then Edison invents the incandescent bulb, and it's a huge breakthrough. And we got up to like 5% efficiency, and at the time, massive breakthrough. Then after World War II, we went to fluorescence, and we got into the 15% efficiency with fluorescent lights, another big breakthrough. Then we went to high-intensity discharge, high-pressure sodium, another big breakthrough. We got into the 30% efficiency of electric lighting, and we thought, oh my God, this is incredible. Guess what? Now we are at LEDs that are 80% efficient. That's why it's the end of the road. You can't get past 100, and the LEDs are going to creep up toward 100. It's just amazing.
Yeah, theoretically, LEDs can become 100% efficient. I will never get to 100, but at some point we'll be at 95% efficiency. Yeah. And that's why I think it's pretty easy to predict that there is not going to be something else that comes along that is going to be even better than LEDs.
Yeah. We talk a lot about the light to heat ratios of things, and light is good, heat is bad. And LEDs, interestingly enough, when you calculate the light to heat ratio of sunlight, the energy in the photons versus the total energy of the sun, you get about 2 micromoles per joule from the sunlight. And this is the photosynthetic photon flux divided by total energy. And LEDs, now we're past 3 micromoles per joule. It's amazing. LEDs have caught up and passed the sun for efficiency.
That's a fun stat. I'd never really thought about the efficiency of the sun, but that makes sense, and it is a really good indication of how good these LEDs are now. And then the other exciting thing, of course, is that with these LEDs, unlike the high-intensity discharge lights, we can get that precision control. That was never going to be possible with HID lights. So it's not just the efficiency, it's also the controllability of these LED fixtures that is going to be really beneficial. When you think about commercial buildings, in many cases, those lights are already dimming automatically in response to how much light is coming into the building.
Right.
You don't notice it because it is gradual and your eyes adjust to it, but it is one other way in which we can use these LEDs to be really energy efficient.
Yeah. Well, that's why we wanted to have this discussion about precision timing of delivery, because when people think about LEDs, they're all about, okay, what's the optimum spectra and what colors should I use? And that's a huge subject which we've talked about many times. But in addition to that, there's this timing of delivery, which is great. It's a new frontier.
And I think that's going to be the next big advance in lighting control in controlled environment agriculture. And it is really important. You think about it, it's obvious in greenhouses where you have the sunlight that is constantly changing. When you think about a plant factory where the cost of electricity is an even bigger part of the overall production cost, right? If they can respond to those real-time pricing changes that are happening, they could substantially reduce their electricity cost. That is going to require collaboration, I think, between utility companies and those plant factories, because I think utility companies are going to have to provide incentives for vertical farming companies to implement some of that better approach that can help the utility companies in a big time.
Yeah. You know, one of the things that comes to mind for greenhouses is, as you mentioned recently, if you run your lights late at night, people complain about the light pollution. Well, so shift it. So let's turn them on early in the morning and off earlier. Then people don't complain about light pollution if the lights come on at 4 a.m. But boy, if they don't go off till 10 p.m., there's a lot of heartburn about that. So shift it. The plants are fine doing something like that, something simple like that.
Yeah, it's simple for a greenhouse to just shift that light. It actually creates some interesting challenges from a control perspective, because if we provide a lot of light later in the day, we have already measured how much sunlight that greenhouse got during the day, and so we know exactly how much more light we need to provide during that evening. The challenge is, if we provide light early in the morning, we don't know how much light those plants are going to get later in the day. And so another thing that we need to incorporate, I think, in these lighting control algorithms is forecast of how much solar radiation or how much light is going to be available during the day. And then we can start taking that into account at 3 a.m. when there is no sunlight yet. And luckily enough, those forecasts are readily available because the photovoltaic or solar energy industry is heavily dependent on those forecasts, so they can simply be purchased from a variety of companies.
Yeah.
But that's the next thing that we want to look at.
Yeah. Yeah, no, that's a really good point. As we do more solar PV, this forecasting gets super important for them too, to match supply with demand.
Yeah, and we're just lucky that that industry is so dependent on that forecasting, because if it was just the greenhouse industry, I don't think anyone would bother actually developing these forecasts.
Yeah.
But they're readily available and we can take advantage of them.
Well, thanks. This has been a great discussion. As we always say, stay tuned. This is an evolving thing. We keep getting new research data. Things change. We're always looking for ways to explain the basic science and find ways to use the basic science to commercialize it and help a lot of people.
Well, thank you, Bruce, for having me, and thank you for watching our conversation today.
Stay tuned. We'll be in touch. Bye now.